Good evening, everyone. So I hope you're all good. Welcome to my channel. And then today we'll be doing November 2022 paper 1 question 4, which is momentum. Okay, so we'll be doing the question paper since I'm done with the momentum. So let's get on into it. Before everything, you must read the statement. Okay, ball P with a mass of 0.16 kg moving east at a speed of 10 meters per second. Remember, east is what? Positive, as I indicated there. Collides head-on with another ball Q, which is this one, of mass 0.2 kg. It is moving west. West is what? Negative, at a speed of 15 meters per second. After the collision, ball P moves west. So after ball P is now moving west, it means after the collision, the speed or the velocity of the ball P will be what? Negative, okay? And then as shown in the diagram. So before the collision, ball P is going to the east, and then Q is going to the west. After the collision, ball P is going to the west. So now let's start with 4.1. So what is 4.1 saying? It is basically saying 4.1 define momentum. So I told you momentum is the product of mass and velocity of an object. You are done. I need the formula. You are done with the definition. So the formula is P is equals to mv. So the product, it is multiplication mass times velocity. So that's also for. Let's go to 4.2. 4.2.1. They want velocity of PQ after the collision. So the velocity of ball Q, which is this one, after. So which means what you are going to apply this formula. Sum of initial momentum is equals to sum of final momentum. So we know what it is momentum before, total momentum after. So it will be m1 v1 I plus m2 v2 I is equals to m1 v1 f plus m2 v2 f. I need to decide it is the it is the total momentum before, and then this side is the total momentum after. Okay, so you have to be careful there. So what is the first mass? Is 0.16 times 10, and then plus the second one, it is Q, which is what? 0.2 times, it is 15, but they said 15 to the west, so it will be minus 15. And then you see second one, the first mass is 0.16, but what? Right now you have to be careful. They said after the collision, ball P is moving west to the west, so which means what? It is minus 5. And then plus what is the second mass, which is Q. The Q, it is 0.2, but we don't have the velocity of Q, so we'll just have to say V QF. Okay, that's how you can represent it there. So we continue, and then let's now do our calculation. 0.16 times 10 is 1.6 plus 0.2 times 15. Let me check on my calculator. 0.2 times 15 is 3. Okay, or times negative, so it's my plus minus 3, so it's 1.6 minus 3, because this is minus 15, which is now equals to what is 0.16 times minus 5. 0.16 times minus 5, it's negative 0.8. so let's check on our calculations. Negative 0.8 plus 0.2 VQF. So let me do my math. 1.6 minus 3 plus 0.8 is equals to 0.2 VQF. I'm taking everything to this side, so let me check if is only in 1.6 minus 3 plus 0.8. I need 0.8 was negative that side, and then it will be 0.6. okay, it will be negative 0.6. let's see what we'll get. 0.2 VQF divide both sides by 0.2. let's see, divide by 0.2. it is what? Negative 3 is equals to VQF. Okay, but you know what we have to do. You have to say therefore VQF is equals to 3 meters per second west. You can't leave your answer as a negative. Yes, it is -3, but it has to be the direction. You have to include the direction because this thing has a mark. Okay, so that's how you do it. So let's go to the last one, 4.2.2. What does it say? Magnitude of the impulse on ball P. So I didn't teach you the impulse, but today we'll be taught the impulse. So impulse, it is the angithi lapha sigcine sithi F net is equals to delta P over delta T. The time when you are doing the theorem. So this time around you cross multiply, then I'll have F net delta T is equals to delta P. You see, so this is the impulse. So now the impulse is the same as change in momentum, but the difference is it is the unit. So let me just do like this. So F net delta T, which is the impulse, is equals to delta P, which is equals to, what is delta P? M VF minus M VI. So I'll just say M VF minus VI because M is common, so it will be, what is the mass there? I can put 0,16 and then put what? -5 and put what? -10. And then when I do my maths on my calculator, it will give me -3 meters per second, and then it will be 3 meters per second west. Okay, so that's how you do it. So impulse is F net delta T. Oops guys, I made a mistake. The answer is, I was looking at this answer. So our answer will be -2,4 meters per second, and then finally it will be 2,4 meters per second west. Okay, so that's how you do it. So impulse is basically F net delta T, but it will be so